Welcome. Today we're doing a deep dive into something that really, I think, changes the game for what a large language model can be. We're talking about agent skills. And this isn't just, a better way of prompting. This is the core mechanism that turns a general purpose AI into a highly specialized expert, one that's tailored exactly to your workflows, your team's standards, even your own proprietary data formats. Our mission today is to really pull back the curtain on the technical architecture here. What are skills? How do you configure them? And what are the surprisingly clever mechanics that let them get triggered automatically and run super efficiently? You should walk away knowing exactly how they work.
It really is a big architectural leap. The best way to think of a skill is like a self-contained onboarding package for the AI. It's essentially just a folder. And inside that folder, you have your instructions. That's in a file called skill.md and maybe some scripts or reference docs. They basically bottle up expertise. Could be anything from reviewing a PR according to your team's very specific standards to, say, processing a complex financial spreadsheet. And the genius part, like you said, is that this whole package of knowledge only gets loaded into the model's context at the exact moment it's needed. It turns a generalist into a specialist, but only on demand.
Okay, let's unpack that right away because, if I'm a careful engineer, I can already write a really, really long and detailed prompt that tells the AI exactly what to do. So why go through all the trouble of setting up a directory, a skill.md file, this whole structure? What's the fundamental difference between my, let's call it a super prompt and a skill?
That's the critical distinction. The key is that skills are model invoked. They're not just user invoked. With your super prompt, you, the user, have to remember to find it, copy it, paste it in every single time.
Right.
With a skill, the user doesn't have to do anything. They don't type a command, they don't call it up. Claude itself decides which skill to use just by matching the user's request to the skill's description.
So the model is self-selecting its own expertise.
Exactly, based on its understanding of your intent.
That feels like a huge reduction in cognitive load for the user, not just a performance thing.
Yeah.
But if the model is constantly checking all these potential skills, doesn't that make the whole startup process really sluggish?
And that's where the clever architecture comes in. It's a three-phase approach, and it keeps the overhead incredibly low. The first phase is discovery. This happens the moment the environment boots up. At startup, Claude loads only two things: the skill's name and its short description. That's it.
Just the metadata.
Just the metadata. So initialization is super fast, but the model now knows that a specialist, might exist for a future question.
Okay, so then I, the user, ask a question, something like, hey, can you explain this code file for me? And that might match the description of a code explanation skill. Then we hit phase 2.
Then you hit activation. Exactly. When your request matches a description, the model will usually ask for confirmation. Something like, I see you're analyzing code. Should I use the explaining code skill?
And only after I say yes.
Only after you confirm does the full detailed skill.md, the heavy-duty instructions, get loaded into the context window for the very first time.
And that leads to the final phase, execution.
Correct. Now that it has the full instructions, Claude follows them precisely. It's running its specialized role. And that might just be generating text, or it could be running bundled scripts, loading other files, all the powerful stuff we'll get into. But that tiered loading is key to performance.
So if we step back, this architecture gives skills 4 kind of core characteristics that really set them apart from just prompting.
Yeah. That's a good way to put it. First, they're composable. This is where it gets really powerful. You can stack skills together. So Claude can coordinate multiple separate areas of expertise on a single task. You could, for instance, apply a security audit skill and an API formatting skill at the same time to a new piece of code.
You're basically building a custom workflow on the fly.
Precisely. Second, they're portable. You build it once, and that same skill.md file structure works everywhere. In the desktop app, in the code console, through the API, everywhere.
And third is efficient, which we just covered with that tiered loading.
Right. And that leads to the fourth and maybe most important one. They're powerful. And powerful because they aren't limited to just generating text. A skill can include executable code for tasks where you need guaranteed reliability, like, say, complex data validation. Running a Python script is always going to be more robust than hoping the model generates the right logic every time.
Okay, let's shift gears and get practical. If I wanted to build a skill right now, what's the minimum viable setup?
You need two things: a directory and the main instruction file inside it. So every skill needs its own folder. For your personal ones, that's usually in a path like .claude skills my skill name, and the name has to be, lowercase, numbers, hyphens, just to keep things safe and portable across different systems.
And inside that folder, the main event is the skill.md file.
Yep. And that file has two parts you absolutely need. Right at the very top, you have the YAML metadata, which is between those triple dash markers. That block needs a name and, most critically, a description.
And then below that,
Below that is the markdown instructions. This is just clear step-by-step guidance in plain language that tells Claude what to do once the skill is activated. It's the playbook.
that description field seems like the absolute linchpin of this whole system. It's what triggers the activation, and it's only 124 characters. How do you write a good one?
It's all about optimization. The sources really stress this. A good description has to answer two questions for the model. What does this skill do, and when should you use it? If you're vague, Claude will either trigger it too often, or worse, it'll never trigger it when you actually need it.
So if I have a skill for formatting logs, I shouldn't just say, helps with logs.
Exactly. That's useless. You'd want to be specific, use keywords the model can match. Something like prepares raw log files for Splunk ingestion or translates JSON log dumps into a standard format. Specificity is everything.
Let's use the example from the documentation, the explaining code skill. This really drives home the value of consistency.
Oh, it's a perfect case study. Because if you just ask an AI, explain this code, you get a different answer every time. Some are good, some are not so good. But this skill forces every single explanation to follow 4 specific steps. It guarantees a consistent, high-quality output. It makes Claude, first, start with an analogy. Relate the code to something in the real world. Second, draw a diagram using only ASCII art to show the data flow. Third, walk through the code block by block. And fourth, highlight a gotcha common mistake or misconception.
I have to stop you there. ASCII art. Why force that? Why not just ask it to, describe the visual flow?
That's a great question. And it really gets at the practical limitations of the medium. In a lot of places where you'd use this, the output is just plain text. So while a model can describe an image, reliably generating a stable image file, or even structured graph code, inside a text stream is still tricky. ASCII art is, well, it's a robust common denominator solution. It guarantees a visual output that works everywhere and doesn't consume a ton of tokens. It's about reliability.
Reliability over flashiness. Okay, that makes perfect sense. Now let's tackle the elephant in the room, context window size. This is where it gets really crucial. If I have thousands of lines of API docs or internal compliance rules, how on earth do skills handle that without just overwhelming the model?
They solve it with a technique called progressive disclosure. The rule is pretty simple. You put your essential high-level instructions in the main skill.md file, and you keep it short, ideally under 500 lines. Then all the really dense reference material, the full API spec, the regulatory texts, hundreds of code examples, that all goes into separate supporting files, maybe reference.md or examples.txt.
So the skill gets activated with the bare minimum, and only if the task specifically requires looking up, say, a particular function call, does Claude actually go and load that secondary file.
Precisely. It only loads that extra context when it needs to. This keeps the context window focused on what's immediately relevant. Think of the token savings. You're not paying to load a 100-page document for a task that only needs 3 lines of instructions. It's a huge deal for cost and speed.
That's a phenomenal way to manage context. But the other trick is what you call zero-context execution. With scripts, walk us through that because that sounds a bit like magic. If I have a script like validate data.py in my skill directory, how does Claude run it without loading all that Python code into the context?
It's not magic, it's just a clean separation. When the skill runs, Claude treats that script like an external tool. It just executes it in your local environment, completely outside the LLM's own processing stream. The key is that the contents of validate-data.py are never, ever loaded into the context window.
Okay.
Only the script's output, the final result, maybe validation pass or an error message, only that consumes tokens. And that's usually just a few words. It's perfect for anything that needs the rock-solid reliability of traditional code without bloating your context history.
We're now firmly in the territory of the AI acting as an agent that controls local execution, which immediately brings up some big questions about control and security. How do you stop a skill from accidentally or maliciously running tools it shouldn't?
You manage that directly in the YAML metadata. There's a field called allowed tools. So you can specify, for example, allowed tools. Read, grep, glob.
And for anyone listening who isn't a command line pro, can you just quickly define those?
Sure. Think of them as basic file operations. Read lets the AI read a file's contents. grep lets it search for text inside files. And glob lets it find files that match a pattern, like all the .json files in a folder. By locking it down to just that list, when the skill is active, Claude can only use those tools without asking for your permission. If it tries to do anything else, like write to a file, it has to stop and ask you first. It's a critical guardrail for read-only tasks.
That's direct security. You also mentioned isolating complex tasks to avoid cluttering up the main conversation.
Right, that's done using context.fork. If a skill is really complex, maybe a 20-step debugging process, you can have it run in its own isolated sub-agent context. It's like a temporary private conversation for the sub-agent. All its internal thinking, all the tool calls, it all stays in that fork. It doesn't pollute or confuse the main chat history with the user. And beyond that, you can define what are called hooks. These are basically event listeners that trigger at specific points, like pre-tool use or post-tool use, or when the skill stops. This lets you inject your own custom logging or security checks right into the skill's lifecycle.
Okay, so we have these specialized, controlled, efficient skill packages. The next question is, where do they live and who gets to use them?
It's a distributed system with 4 key locations, and this is important. They form a strict hierarchy. If 2 skills have the same name, the one from the higher location in the hierarchy always wins. At the very top, you have managed skills. These are controlled by an admin for the whole organization. Highest precedence. Below that are your personal skills, which live in your user folder, like .claude skills.
Okay, let me stop you there. So if my personal skill says, be super verbose, but the corporate managed skill says, be brief and use the official style guide, the corporate one wins.
The corporate one wins every single time. It's an essential guardrail. So if you're debugging why your skill isn't behaving as you expect, the first place to look is that hierarchy. See if an organizational standard is overriding you. Below personal skills, you have project skills. These are usually in a hidden directory like .claude skills inside a Git repo, so they're shared and version controlled with the team. And at the bottom of the hierarchy are skills that come bundled with plugins.
That structure makes sense. Okay, last piece of the puzzle, visibility. If I build a really important skill for, say, corporate compliance, I want Claude to use it automatically, but I don't want every user trying to call it from a command menu.
That's handled with a simple flag, user invocable, false. Setting that just hides the skill from the user interface. It won't show up in the /command menu.
But it's still active. Claude can still find it.
Exactly. It's still there, ready to be discovered automatically if the user's request matches its description. Or it can be triggered programmatically by another tool. It just ensures your internal standards are enforced silently in the background. Oh, and one last thing on that. This is important for custom subagents. A subagent, say a dedicated code reviewer, does not automatically inherit skills from the main conversation. You have to explicitly list which skills it should have in its configuration. Something like skills.pre-review, security check. This keeps the subagent lean and focused, loading only the expertise it absolutely needs at startup.
That was a phenomenal deep dive into the architecture. We've seen how skills turn a generalist AI into a portable, precise, model-invoked expert, and how they manage efficiency with things like progressive disclosure and zero-context script execution.
Yeah, the real takeaway here is seeing the paradigm shift.
Yeah.
When you can include and execute reliable code, you elevate the AI from a chatbot to a true automation engine. We're moving beyond just summarizing things to running complex multi-step financial analysis or code refactoring workflows. All of that becomes predictable automation packaged into a single skill.
It transforms the AI from a conversational partner into an active, specialized agent doing real production work inside your environment.
Absolutely.
Which brings us to our final thought for you to chew on. Since this capability grants the AI access to execute code in your environment, whether that's a Python script for validation or a Bash script for security checks, what new level of scrutiny and trust must developers now apply? I mean, when you're deciding whether to install a skill from a third-party marketplace or even run one built internally, you're not just prompting anymore. You are granting a model the authority to execute code in your workspace. It transforms a simple prompt into a fundamental security-aware decision about code execution. What code are you truly trusting this model to run?